Hi everyone, here we go, different types of parabolas. There are three basic forms of how we write a parabola. It's not the parabola themselves, it's how we write a parabola. First one is the obvious one, is that ax squared plus bx plus c. What can we get from the information when it's written like that? For starters, we basically start with a being 1. So then if I had 5x plus 6, which is the most common one I keep going back to, on some of the other videos we looked at solving equations. So this is just the parabola. Now I'm back to, I talk about all the time, my equals off times 1. Is there a need to factorise? Is there a need to make it equal to 0? And the thing is yes. These are not straight lines, these are parabolas. Once you get to a parabola, if we let y equal 0, or if we let the parabola itself equal 0, there's our equal 0. The next F is about fractions. Do we need to use fractions? Are there any fractions involved? And the answer is obviously no. Next one stands for factorise. Do we factorise that? Yes. Back to this idea, two numbers that multiply to 6, they add up to 5, and the obvious two answers are 2 and 3. So how can they get two brackets with an x squared? The x goes there and the x goes there. The 2 and the 3 is the 2 and the 3 there. If everything's positive, this is all positive. Now we're back to quadratic equations, which we had in our video before. So what can they do? Either the first bracket has to equal 0, or the second bracket has to equal 0. So what does that tell us? If I take 2 from both sides, I get x equals minus 2. Or I've got, take 3 from both sides, I get x and minus 3. So there's two possible answers for that quadratic. But what do they have to do with this up here? They're now not the answers to the quadratic. They're the roots or the x-intercept of the parabola. So the solutions of a quadratic are where the parabola crosses the x-axis. So if I go over to here, I can go to minus 2 and minus 3, and I can put a dot there and I can put a dot there. I now know that the parabola goes through at minus 2 and minus 3. This was actually saying let y equal 0. So what does it do when we get let y equal 0? It gives us the x-intercepts. So the next thing I'm going to need is the y-intercepts. How do I get the y-intercepts? Let x equal 0. So we have y equals, and we're back to here, 0 squared plus 5 times 0 plus 6, we've got y equals 6. So if we wrote as coordinates, that's 0, 6. If we wrote these as coordinates, that's minus 2, 0 and minus 3, 0. And a lot of people get mixed up and writing the wrong way around and lose marks from silly things. So we now know it also goes through 0, 6. Now there is a symmetry to every parabola, so what you have on one side you have on the other side. So if I went across here and up to there, you might notice from here I've gone across 2 and up 6. It's not rise over the run. So if I go across 2 to minus 5 and I go up 6 there, there's my basic parabola. The annoying part on my diagram here is there's a line down the middle, and the line down the middle is called the axis of symmetry. So much in parabolas, this is where people get mucked up in parabolas. And we're only doing the first form. I've said the three basic forms, we'll only do the first form on this. Now the axis of symmetry has an equation. All vertical lines are called. Are they x equals, are they y equals? They all are. X equals, that's x equals minus 2.5. Halfway between minus 2 and minus 3, that was a good shot. So now I can draw the parabola down here. Here's the interesting about parabolas. When we're using a 1 over here, if they're apart by 1, it so happens that they're going down by a quarter. So if I try to draw it to scale, there's about there, that's where my parabola is there. So the bottom point, which is called the minimum, is minus 2.5 and minus a quarter. Now the calculating of the minus quarter is substituting minus 2.5, and I should have picked a better example. If I picked one that was minus 2 and minus 4, or even 2 and 4, the numbers will work out nicer for the axis of symmetry and for the minimum point. Another name for the minimum is we talk about all minimums and max as a turning point. So if you hear us talking about turning points, that means we don't know whether it's going to be a min or a max, or we're not going to say to you it's a min or a max. We want you to figure out which one it is. So look at the details we've got. You let y equal naught just like usual. You let x equal naught just like usual. And that gives us the x-intercepts and the y-intercepts. Where's the axis of symmetry? Halfway between the roots, or the x-intercepts. So its equation's easy enough to get. How do we get this bottom point down here? That's the thing I haven't explained as yet. This is where it gets so long to explain all these details. I'd have to substitute minus 2.5. And I think I'll leave that to the next video. Thank you.